Welcome. This video describes the Introduction to Computational Thinking class, CS 1014. After viewing this video, you will be able to identify the course staff and know how to contact them, locate all of the course materials, define computational thinking as it is used in this class, describe the objectives and organization of the course, explain the active learning model that we use in this class, and state the University Honor Code and explain how it applies to the elements of this class. So let's get started. There are two sections of the class being taught this semester, one by Dr. Kafura and one by Dr. Bart. Javier Thibault is a GTA for both of these sections. Each section also has 5 UTAs. All of the UTAs have taken the course before, and as you can see, they're from a wide variety of majors. This reflects both the fact that there's a diverse audience for this course across the university, and also living proof that students from many majors have succeeded in this course in the past. Taking the course this semester are students from 32 different majors, and in each academic year with about half of the class being first-year Hokies. There's plenty of opportunity to interact with all the course staff each day in class. Office hours can also be scheduled on request using the email addresses that are shown here. The email contact for your UTA will be given to you later. All of the materials for the class can be found on the university's Canvas website. So if you log into canvas.vt.edu using your Virginia Tech username and password, you'll be able to select the Introduction to Computational Thinking class from the menu of courses that you'll see displayed. One way of viewing the material in the class is through the module view. This view gives you a day-by-day listing of the materials for each day. As you can see here, each day consists of a reading, which you should read before coming to class, and also before coming to class, taking the associated reading quiz. You'll also see the slides that will be used for the short lecture each day, as well as classwork and homework problems. Each day is part of a module, and it's important to note that of the 7 modules in the class, each of them has an associated closing date. Canvas calls this a lock date also. The importance of this date is that all the material, all of the problems and graded work for that module must be completed before the closing date. Another useful view in Canvas is the calendar view. This view shows all of the due dates and for all of the assignments throughout the class. These due dates reflect when the work should be completed for best learning and to stay up to date with the class. Work can still be submitted past this due date, but only up to the closing date of that module. In general, reading quizzes are due at the start of the class, classwork is due at the end of that class, and homework in one class is due before the start of the next class. Finally, on Canvas you will also find the course syllabus. While some of the information in the syllabus is going to be presented here in this video, it's important that you read the syllabus completely because it represents the contract for the course and it gives you more detail about some of the issues that are discussed in this introduction. At this point in the class, students who are in class would be taking the first reading quiz. So if you did not take this quiz in class, you should do so now. Since you're not expected to have done any reading before the first class, this first reading quiz asks some general questions about how computation is used in your major field of study. But keep in mind that future reading quizzes are about the assigned reading for each day. At this point in the first class, students were asked to discuss with others at their table 3 questions that asked about what you think the term computational thinking means, why are you taking this class, and your experience with having learned something new and different in the past. If you're not in the class and completed this assignment, you should download the PDF form of these questions from Classwork 1, complete your answers, and give your answers to one of the course staff. As used in this class, the term computational thinking is the combination of two very powerful ideas in computing. The first is abstraction, which is the ability to represent or model entities in the real world by a collection of information properties that describe relevant aspects of that entity. In this class, big data sets containing abstractions of real-world things from earthquakes to crime will be used. The second big idea is that of an algorithm. This is a precisely defined process by which a computer is instructed on how to manipulate an abstraction. In this class, the algorithms we will create manipulate the big data sets to answer questions about the real world. As we have just seen, the technical ideas of abstraction and algorithms gives us the ability to model the real world and to explore that world computationally. But in this class, we will also study how these technical abilities have impact on society, affecting the lives of real people, in some cases in a positive way, and in other cases in a negative way. In completing your projects in the class, you will be asked to consider the social impacts of your project. The class has 4 high-level learning objectives. The first objective relates to the idea that computation can be used in any field of study. We will see this by working with abstractions and data from a variety of real-world situations and by interacting with other students in the class from a variety of majors. The second objective relates to using computational thinking to ask and answer questions. We will do this by developing algorithms that help us to answer questions. The third objective relates to using computation to deal with complex real-world phenomena. We will do this by learning how complex data descriptions are organized and learning how to write algorithms for such data. The fourth objective relates to how computing has impact on society. We will do this by learning a model of how computing has social impacts and learning how to apply this model and ethical theories to specific cases. The 4 projects in the class are an important way for you to demonstrate your achievement of these learning objectives. Here's a very high-level view of how the course is organized. The 4 major activities in the course are algorithms and abstraction, the 2 technical ideas underlying computational thinking, social impacts, how computing affects people, and the 4 course projects. We will progress through the course in a series of spirals. On each spiral, we will learn more about algorithms, abstractions, and social impacts, and do more on each of the projects. The first cycle is completed in the first 2 weeks. In this cycle, we will use already prepared algorithms to visualize information that helps us to answer a question and begin using the model of social impacts. The first cycle ends with a short, quick project called a nano project, the name suggesting that this is a small project. The second cycle takes the next 5 weeks to complete. In this cycle, we will develop algorithms in a safe and supportive language that's referred to as a block language. These algorithms that we develop in the block language will process long lists of data to compute properties about that data. So-called stakeholders, those affected by computing, will be identified. This cycle ends with a project lasting several days. This project is called the micro project. The third and last cycle is one where a popular text programming language, named Python, is used to manipulate highly complex data. Ethical principles will be explored to make judgments about the social impacts of computing. This cycle takes fully 8 weeks to complete and ends with 2 back-to-back projects. The first of these 2 projects is called the mini project, and this is done with some degree of collaboration among teams of students. An individual final project is the last activity in the course. This is a major undertaking where you can demonstrate your ability to bring to bear all of the knowledge and skills that you have developed in the class. About 3 weeks of class time is devoted to this project. Another way to view the organization of the course is through the more detailed components that make up the ideas of abstractions and algorithms. These are shown on this table of computational elements. We will learn these building blocks of computation, starting with a few building blocks and adding more as we go. While there are only a few building blocks, these are enough to write any algorithm. More complex algorithms and abstractions can be created simply by putting these building blocks together in new and complex ways. Just as when building with Legos or creating a mosaic, you can create large and complicated constructions with only a few basic shapes. A final way to view how the course is organized is in terms of the grading scheme. As you can see, the classwork and homework are half of the final grade. The 4 projects combined are 30%, and the attendance and reading quizzes are each weighted at 10%. As you will quickly see, most of our time in class will be spent working on problems, building and analyzing abstractions, writing algorithms, and interacting with other students in the class. As you will see in the class, everyone is seated at a 4-person table. These 4-person groups are called cohorts. On the 3rd day of the class, you will be assigned into a permanent cohort, permanent in the sense that you will keep meeting together throughout the semester. The cohorts are organized to have 4 different majors in each cohort wherever possible, allowing diverse perspectives to be brought to bear in your learning about computational thinking. The cohort is a peer learning group. You are strongly encouraged to help each other master the concepts and skills in the class by interacting to help each other, asking questions about the problems, giving help when another cohort member is stuck, offering encouragement to continue, or congratulating them on their success. Shortly after the cohorts are formed, we will have you write a cohort contract, stating the obligations that each member in your cohort has to themselves and to the others in the group. The cohort is at the very center of the learning in this class. The UTAs, the GTA, and the instructor are here to help support this learning. But what does it take to succeed in this active learning environment and to be a good cohort member? Well, first, be prepared for each class. Complete the reading and the reading quiz before coming to class. Second, come to class. Be there to interact with your cohort and to get help from them and the course staff. Third, keep up with your cohort and the class by meeting the due dates. And lastly, be sure to complete all the work on a module before that module closes. Fortunately, the class is designed to help everyone succeed. All of the critical concepts are seen on each of the 3 cycles that we take through the course. You only need to get these concepts once to have it mastered. Make a good faith effort to do all of the coursework and you will get a passing grade. Others from your major have succeeded before, so can you. But lastly, you're not alone. Your cohort members, the UTAs, and all the staff are here to help. And in looking ahead, the final project is largely yours to define, and about 3 weeks of the class time is devoted to this activity. The Virginia Tech Honor Code statement shown here is a pledge to maintain personal integrity in our academic pursuits and to expect similar integrity from everyone else. This standard of conduct applies to all work in this class. If you observe violations of the Honor Code in this class, you should report this to the course instructor. But how does the Honor Code apply in an active learning class where collaboration within your cohort is strongly encouraged? The general guidance is that this class is all about the learning. You're encouraged to collaborate with your cohort members and to seek help from the UTAs and the other course staff, but simply providing or accepting significant parts of answers is not allowed because this does not represent real learning. It is avoiding the learning. More specifically, your work on the classwork, homework, and mini-project is intended to be highly collaborative within the guideline just given about the central role of learning. Your project should clearly represent your own work and be a clear expression of your understanding of the course material. The algorithms that we write in either of the two languages that we will use should be something that you wrote, understand, and can explain. You should see the course syllabus for more details, and in general, if you ever have any doubts, ask the course instructor. There are many levels of learning in this class, and it is a place where we as instructors are also learning. As part of our endeavors in the research of computer science education, we use this class as a laboratory to use and assess innovative educational practices and tools. We've written research papers based on our experience and have funding from the National Science Foundation to support this research. We will be asking you to give your consent to allow us to use the data we have collected in this class as part of the research, with the understanding that none of the reported research will allow you to be identified. Though we would appreciate your consent, this consent is purely voluntary and has no influence on your grade or on your other participation in the class. We'll have a form for you to sign in a few days. Well, that's it for the start. The next step is to get ready for the next class meeting. Do the homework that's assigned for today, and do the reading and the reading quiz before our next meeting. I'll see you then.